Here is a question on general organic chemistry. Read the question carefully and think about the answer. Let us solve it step by step. Let us now begin solving this step by step. Structure: A cyclohexane ring with a carbon bearing a positive charge that is connected via a double bond, C plus is equal to C, making it an allylic or vinylic carbocation. Looking carefully, the positive charge is on a sp2 carbon that is part of a double bond, C is equal to C with the plus on the adjacent carbon, making it an allylic carbocation with the cyclohexyl ring. This is actually a tertiary allylic carbocation. Structure: To a cyclohexane ring with an exocyclic CH2 plus group, which is a primary carbocation, or the plus is directly on the ring making it secondary. Based on context, this appears to be a secondary carbocation, cyclohexyl cation. Structure: 3. A cyclohexane ring carbon bearing both a methyl group and a positive charge. This is a tertiary carbocation, 1-methylcyclohexyl cation. Structure: 4. A cyclohexane ring carbon bearing a positive charge with no additional substituents. This is a secondary carbocation, cyclohexyl cation. Moving on to the next step. Tertiary carbocations are more stable than secondary, which are more stable than primary. Allylic stabilization, resonance delocalization, also provides significant stabilization. 3. 1-methylcyclohexyl cation, tertiary carbocation, highest stability among simple carbocations here. 4. Cyclohexyl cation, secondary carbocation next. 2 appears to be a secondary carbocation similar to or slightly different from 4. I. The carbocation in structure I has the plus charge on a sp2 carbon of a double bond, vinyl cation character, even though it is attached to a cyclohexyl group. A vinyl allylic carbocation where the positive charge resides on the doubly bonded carbon is less stable than a typical secondary or tertiary carbocation. If the plus is directly on the vinylic carbon, sp2, it is a vinyl cation, which is less stable than secondary carbocations. Thus, I is least stable. Moving on to the next step. 3, 4 to I. And for the final step. A, 2, 3, I, 4, incorrect ordering, places to above 3. C, 3, 4, I, 2, incorrect, places I above 2. D, I, 2, 4, 3, incorrect, places I as most stable. Option B, 3, 4, 2, I correctly places the tertiary carbocation first, followed by secondary carbocations, and the vinyl type carbocation, I, last. Therefore, the correct answer is B. Therefore, the correct answer is option B.